Let us now understand what is called the inclination of a line. The inclination of a line is the angle which the line makes with the positive direction of the x-axis. If theta is the angle between the x-axis and the line in the anti-clockwise direction, then it is called the angle of inclination. So here you can see the line L making an angle with the positive direction of x-axis, and this angle is made in the anti-clockwise direction starting from the x-axis. So this angle which is made by the line with the positive direction of x-axis in the anti-clockwise direction is called the angle of inclination. Here you can see the angle is acute. Here also the angle is made between the positive direction of x-axis and the line in the anti-clockwise direction, but here the angle is obtuse, right? So the angle which the line makes with the positive direction of x-axis in the anti-clockwise direction is called the angle of inclination. Now, if the angle is measured in the clockwise direction, that means if the angle which the line makes with the positive direction of x-axis in the clockwise direction, then the inclination is taken as negative. So we have already mentioned that the angle which the line makes with the positive direction of x-axis in the anti-clockwise direction is called the angle of inclination, that is we denote it by theta. But if it is measured in the clockwise direction, the inclination is negative. A line parallel to x-axis is called the horizontal line and its inclination is 0 degree, because any horizontal line means the line which is parallel to the x-axis, its angle with the x-axis will always be 0 degree. Hence theta is 0 degree, that means the inclination is 0 degree. A line parallel to y-axis is called the vertical line, its inclination is 90 degree. So any line parallel to y-axis is the line which is perpendicular to x-axis, hence the angle made by this line which is parallel to the y-axis and is perpendicular to x-axis is 90 degree, so its inclination is 90 degree. A line which is neither parallel to the x-axis nor parallel to the y-axis is called an oblique line, and we have already discussed its inclination can be positive, means either acute or obtuse. So in the final point, a line which is neither parallel to the x-axis or the y-axis is called an oblique line and its inclination is either acute or obtuse. Now we'll see what is called the gradient or slope of a line. When theta is the inclination of a line, then tan theta is called its slope or gradient. Slope or gradient is denoted by the letter m. So if you know the angle of inclination theta, then tan of that angle theta is called the gradient or slope of that particular line. Now to find the slope when theta is given, so when the theta is known, how to find the slope? So if theta is acute, slope is positive. That is, you can see this is the line which makes an angle theta with the positive direction of x-axis in the anti-clockwise direction. If theta is the angle, then the slope is given by tan theta, which is denoted by small letter m. So the theta angle of inclination is 30 degrees, then the slope is tan 30 and that value is 1 by root 3. If the angle of inclination is 60 degrees, then the slope or tan is the tan theta, that is the value of m is equal to tan of 60 and that value is equal to root over 3. Now here if the angle theta, that is the angle of inclination, is obtuse, then the slope is negative. You can see this line L making an angle of theta degrees with the positive direction of x-axis in the anti-clockwise direction, but it is obtuse angle. So if it is obtuse, then the slope is negative. So here theta is the angle, slope given by tan theta, which is denoted by m. Angle of inclination is 135, that is tan of 135 given by tan of 180 minus 45 equals to minus of tan 45, whose value is minus 1. So I see that if the angle theta is obtuse, then the slope is negative, that is minus 1. Similarly, if the angle of inclination is 120 degrees, which is also an obtuse angle, then tan of 120 degrees coming to minus of root 3, which is negative. So what we finally have, that if the angle theta is obtuse, the slope is negative. Now if the angle theta is 0 degree, then the slope is given by slope equals to tan of 0 degree and that comes to 0. So all lines which are parallel to x-axis have slope equals to 0. Fourth point, if the angle theta is 90 degree, then the slope is given by tan of 90 degree, which is not defined. So these are the four cases we have studied for finding the slope when the angle of inclination is given. So the first was when the angle is acute, then the slope is positive. If the angle is obtuse, then the slope is negative. If the angle theta is 0 degree, then the slope is 0, and if the angle theta is 90 degree, then it is not defined. Now the second point to study is to find the slope when a line is parallel or perpendicular to a given line. If the lines are parallel, first case, if the lines are parallel, then their slopes are equal. So in case you have two lines which are parallel lines, then their slopes will always be equal. Here are two lines L1 and L2. The angle of inclination is theta 1 and this is theta 2, and you can see if these are parallel lines, then the x-axis acts as the transversal, and these two are corresponding angles, hence they are equal. So theta 1 is equals to theta 2, then we can write tan of theta 1 is tan theta 2, that is f1 equals to m2. That means for parallel lines, that is if the lines are parallel, then the slopes are equal. Now the second point is, if the lines are perpendicular to each other, then the product of their slopes is equals to minus 1. In the previous case, when the lines are parallel to each other, the slopes are equal, but in this case, if the lines are perpendicular to each other, then the product of the slopes is equals to minus 1. Now let us see how. This is the line L1 and this is the line L2. This line L2 makes an angle theta with the positive direction of x-axis in the anti-clockwise direction, and since the lines L1 and L2 are perpendicular, so this angle is 90 degree and this angle is theta, so this angle PRX, which is the exterior angle, and that is equals to 90 plus theta, that is the exterior angle property, that is the exterior angle equals to sum of the interior opposite angles, that is 90 plus theta is this angle, 90 plus theta is equals to this 90 plus theta, this is 90 plus theta. Now since L1 and L2, that is the two lines are perpendicular, so angle QPR is 90, and let angle, we have assumed it as theta, so angle PRX is 90 plus theta, that we have already discussed right now. Now slope of L1, this is the line L1, so slope of L1, that is 90, inclination is 90 plus theta, so the slope is tan of 90 plus theta, and tan 90 plus theta is minus of cot theta, and that is equals to minus of 1 by tan theta. Okay, so we have the slope of the line L1 as minus 1 by tan theta. We come to the slope of this line L2. Theta, angle of inclination is theta, so the slope is tan theta, right? Now if we multiply these two, slope of the line L1 multiplied by slope of the line L2 is equals to minus 1 by tan theta into tan theta, and that is equals to minus 1. So the product of the slopes m1 into m2 equals to minus 1. So if you know the slope of any one particular line, then the line which is perpendicular to it, the slope is also known to us. So the slope of m1 is the negative of the reciprocal of the slope of the line L2. So m1, if m1 is the slope of the first line, then the value of the slope of the first line will be equal to the negative of the reciprocal of the slope of the second line. Now let us see how to find the slope of two given points. This is a line AB, the angle of inclination is theta. So if you take any 2 points A and B on this line, so let the coordinates of A is x1, y1, that of B is x2, y2. So you know that this distance is x1 and this distance is x2. Similarly, this distance is y1 and this entire distance is y2. So the difference of these two, that is from this part is the total, this minus this, that is x2 minus x1. Similarly, this part is y2 minus y1. Now we know that in the trigonometrical ratios, tan of angle theta, see this angle is theta, so this is also theta because they are corresponding angles. Now tan of theta is given by perpendicular by base. So we have, if the 2 points are A x1 y1 and B x2 y2, then the slope of AB, that is tan theta, is given by perpendicular by base, that is y2 minus y1 by x2 minus x1. So tan theta is y2 minus y1 by x2 minus x1, or you can write it as y1 minus y2 by x1 minus x2. That means tan theta, or the slope of these 2 points is the difference of the ordinates divided by the difference of their abscissa. Now we will try to find the slope when the equation of a line is given. If the equation of a line is given, then write it in the form of y equals to mx plus c. When you write this equation in the form of y equals to mx plus c, that is y on the left hand side and the term containing x and the constant terms on the other side, then the coefficient of x, that is coefficient of x is m here, that is m is the slope of that particular line. So you have to express, you have to write the given equation in this form where y equals to mx plus c, m is the coefficient of x is the required slope of this line. For example, we take the equation of a line as 3x plus 4y equals to 6. Then we have 4y equals to minus 3x plus 6. Y equals to minus 3 by 4x plus 6 by 4. That is y equals to minus 3 by 4x plus 3 by 2. Now we have told, see, comparing this equation with this y equals to mx plus c. Below this we write the y equals to minus 3 by 4x plus 3 by 2. If you compare these two, what is the coefficient of x? That is minus 3 by 4. Then the slope of this line is minus 3 by 4. And this is equal to c is 3 by 2. C means the y-intercept. We'll come to that later on. So right now you understand that the y-intercept is equals to 3 by 2. So to find the slope of the line, slope of a given equation, write the equation in the form of y equals to mx plus c. Then the coefficient of the coefficient of x gives the slope of the line and the constant term gives you the y-intercept. Let us now understand what are called intercepts. If a line intersects the x-axis at a point A, then the abscissa of A is the x-intercept. Similarly, if a line intersects the y-axis at the point B, then the ordinate of B is the y-intercept. It will be clear. See to this particular line. This line intersects this x-axis at the point A and the y-axis at the point B. So what is the abscissa? What is the value of x here from the origin? This is 5. Then this is called the x-intercept. Similarly, the value of y from the origin on the y-axis is 3. Then OB, that is equals to 3 units, is the y-intercept. In the second diagram you see A is on the left hand side towards the negative sides, it is minus 4, 0, so the x-intercept is minus 4 and the y-intercept, since it is in a downward, so it is minus 3. So x-intercept minus 4, y-intercept minus 3. The x-intercept 5 units, 5 and y-intercept is 3 units. That means intercept can be negative as well, right? So if a line intersects the x-axis at a point A, then the abscissa of A, this is the abscissa of this point A which is intersecting the line on the x-axis. Then the abscissa of A is the x-intercept, and if the line intersects the y-axis at the point B, then the ordinate of B, then here you can see the 3 ordinate, then the ordinate of B is the y-intercept. Okay, one more thing let me tell you. If the line is parallel to the x-axis, then the x-intercept is 0. If the line is parallel to the x-axis, then the x-intercept is 0. Similarly, if the line is parallel to the y-axis, then the y-intercept is 0. Again I repeat, if the line is parallel to the x-axis, then the x-intercept 0. If the line is parallel to the y-axis, then the y-intercept is 0. But if the line is passing through the origin, then both the x as well as the y-intercept are 0. Let us see now, why do we find the slope of a line? We find the slope of a line to find the equation of a line. Secondly, to prove that 3 points are collinear, that is they lie on the same line, and to prove that the 2 lines are parallel or perpendicular to each other. So to find the slope of a line, to find the equation of a line, to prove that the 3 points are collinear, that we have already done in the previous section, that is by the distance formula, And to prove two lines are parallel or perpendicular to each other. Two lines are parallel if their slopes are equal, and two lines are perpendicular if the product of the slopes is equals to -1. Now let us see to the question here. Prove that a 6, 6, b -2, 0 and c 2, 3 are collinear points. Now this particular question we have already solved in the previous section when we were discussing about the distance formula. There we have done it like this, that AB plus BC equals to AC. So either of the three combinations that you have taken. So here we will be proving the same thing, that we will prove that the points A, B, C are collinear by the method of finding the slopes. Now the condition is that slope of AB should be equal to the slope of BC. So if the slopes are equal, that means they lie on the same line. So we have slope of AB, that is y2 minus y1, so 0 minus 6. Right. Slope of AB. 0 minus 6 minus 2 minus 6. This is minus 6 divided by minus 8. That comes to 3 by 4. Now what is slope of BC? 3 minus 0 divided by 2 minus minus 2. So that comes to 3 by 4. So we see that the slope of AB and the slope of BC are equal, and hence we can say that the 3 points A, B and C are collinear. So we can prove this by the two methods, one by the method of finding distance formula, that is AB plus BC equals to AC, or we can use this method of finding the slopes, that is slope of AB equals to slope of BC, and then we can say that the 3 points A, B and C are collinear. Question number 2. Given A, k, 4, B 6, minus 3, C is 1, 8 and D 5, minus 6. Now you need to find the value of k if AB is parallel to CD and AB is perpendicular to CD. Now we know the conditions. In terms of the slopes, AB is parallel to CD. When AB is parallel to CD, that means the slopes of AB and CD are equal. If AB is perpendicular to CD, that means the product of the slopes is equals to -1. So we need to find the slopes of AB and CD, and then we will proceed according to the given conditions. So let us first find the slope of AB. Slope of AB is -3 minus 4 by 6 minus 8. And that is equals to -7 by 6 minus 8. Then slope of CD, -6 minus 8 divided by 5 minus 1. So this comes to -14 by 4. So it comes to -7 by 2. Now slope of AB we got -7 by 6 minus k, and that of CD is minus of 7 by 2. Now let us start with the first condition, that AB is parallel to CD. In that case the slope of AB and CD are equal. So condition is AB parallel to CD. So we have -7 of 6 minus k equals to -7 by 2, or we can write this -7 cancels, so we have 6 minus k is equals to 2, or k is equals to 4. So the value of k is coming to 4 when the two lines AB and CD are parallel to each other. Now let's see to the next part, that is condition is, that is when AB is parallel to CD. So in that case what we know, that the product of the slopes is equals to -1. So we have, if we take it as M1 and if we take it as M2, the condition number 2, AB is perpendicular to CD. So you can write M1 into M2 is equals to minus 1. That means minus of 7 divided by 6 minus k multiplied by minus 7 by 2 is equals to minus 1. So 49 to, that is this negative symbol, this is 49 will be equals to 2 into 6 minus k. So 49 is equals to 12 minus 2k, or 2k equals to, am I going right? 12 minus 2k, this is minus 1, minus 7 minus 49. Oh, this will be minus, sorry. This again. Here it is minus 49 by, so 49 is equals to minus twice of 6 minus k, that is 49 equals to minus 12 plus 2k, or 2k equals to 61. So finally we have k equals to 61 by 2. So finally we get the value of k as 61 by 2 when the condition is that the two lines AB and CD are perpendicular to each other. So whenever such questions comes in front of you, that when the two lines are parallel to each other, you directly take the slopes to be equal, and in that case if you need to find the unknown quantity that will be obtained from this condition, then the slopes are equal. In case the lines are perpendicular to each other, then the product of the slopes equals to minus 1, and then the unknown quantity can be obtained by applying this particular condition. So have a look